We're going to be looking at solving trig equations now. And these next two, well, we're continuing to look at solving trig equations. And these next two involve equations where our period has changed from what I think of as the normal or standard period of 2 pi for sine and cosine and pi for tangent. And that's going to have implications for the number of answers that we're going to get. Taking a look at this first example, we have sine of x over 3 is equal to 1/2, and we're going to be looking at solutions only from inside our normal period of 0 to 2 pi. Now, if we look at this, we can see here that our b is 1 over 3. Some of you have gotten stymied with this in the past, not knowing if b was 3, but it's 1 over 3. Just push that x away because remember b is the number in front of the x, so just push the x away. And when you take the x out of the numerator, you're left with that invisible 1 over 3. So b is 1 over 3. So our period then, which is 2 pi over b, since b is 1/3, we have 2 pi over 1/3, and this gives us a period of 6 pi. So our period is not 2 pi, it's 6 pi. So what I want to do is I want to take a look at how this looks graphically and our answer, and then we'll come back and we'll do it algebraically, if you will. So here I have a graph. This looks like a regular sine curve for us. And if you don't look closely at these x values here, are angles. I mean, it looks like a regular old sine function here, amplitude of 1. So we got +1 and -1, and there we go. The difference is this is not a regular sine curve between 0 and 2 pi. This represents the problem that we're looking at, where sine is x over 3. So the period is 6 pi here. And looking, we can see, I hope that you can see here, that here is our 2 pi. So between 0 and 2 pi, I'm going to make a line here. That is where we normally have a complete cycle. We need to go from 0, here is our 6 pi. So it takes between 0 and 6 pi to make a complete cycle. Our equation says that the sine of this is equal to 1/2. So if I come to, there's the equation we're solving. So looking here at this graph, here's where y is 1/2. So we can see we have an answer there. We can see we would also have an answer over here, right, at 5 pi over 2. However, 5 pi over 2, this is beyond our 2 pi. This is beyond where we're looking for our answers. So between 0 and 2 pi, we're only going to have one answer, because even though there are two potential values for that 1/2, because we've changed our period, this one we ignore because it's beyond where we're looking at. And if we go down to our x-axis here, we can see that the answer is pi over 2, that this happens at pi over 2. This is where we get our trig function of 0.5. So now let's go back and see how we're going to do this and get that answer algebraically. So what I'm going to suggest is we're looking at sine of pi over 3. Let's simplify that, because we're basically looking for some angle. So let's just call it that. So what I'm going to say is let x over 3 be theta. Let's just call it theta like we're used to. So we're looking for the sine of theta is equal to 1/2. And this is positive. So we know that we're going to have a theta that's going to be from Q1, and we're going to have a theta from Q2 because sine is positive in Q1 and Q2. So in Q1, the angle that has a sine of 1/2 is pi over 6. And then in Q2, the angle that has a sine of 1/2 is 5 pi over 6. So here are the two angles that we would use if we were in the world of 0 to 2 pi and if we didn't change our period, which we did. So what we have to do now is take our, I'm going to call these the basic angles, if you would, from our period of 0 to 2 pi world, and we're going to have to find what they are now in this world where we've changed up our period. So to do that, I'm going to take this pi and replace it now with this x over 3. So I'm going to say that x over 3 is equal to pi over 6, and x over 3 is equal to 5 pi over 6. So undoing that substitution. Now we have to continue here. Remember in the other examples, what we did was we added this 2 pi n and 2 pi n, and that enabled us to represent all possible answers that we could be looking for. So we're going to take the two angles we find, and we're going to add 2 pi n. And now we're going to just do some algebra that we know and love to solve this. We have x over 3, so we want plain x. So we're going to multiply everything by 3. And when I say everything, I do indeed mean everything, every term here. So these cancel over here. Let me put a line here because this is getting kind of squashed looking. And over here, we're left with x is equal to 3 pi over 6. This is going to reduce to pi over 2 plus, and this here is going to be 6 pi n. 3 times 2 is 6. And then over here we have x is equal to 5 pi over 2 plus 6 pi n. So we've just multiplied, in this case, everything by 3 to solve for our x's. So here are our two values being changed up now for our period change. So we have this information, and this is in the general form where we have n. Well, we don't want an answer with n. So what we're going to do is start substituting for n. So where we're going to start with these is n is equal to 0. So when n is equal to 0, here my answer is going to be pi over 2. And then when we put a 0 in here, this all goes to 0. So this is pi over 2 plus 0, or just pi over 2. And pi over 2 is in here, back here. That is indeed between 0 and 2 pi, so that answer is good. So now let's take a look at n is 1. So now we have pi over 2, and now we put a 1 in for the n. So 1 times 6 pi is 6 pi, so we have pi over 2 plus 6 pi, and we could add that, but I don't need to. I'm just crossing that out because plus 6 pi, that's way beyond the 0 to 2 pi that we're limited to. So from this first answer, we only have pi over 2. And if some of you are remembering our graph, you know that this is it. This is the only answer we're going to get, but let's prove it here. So here, again, on this side, let's look at n is 0. So we have 5 pi over 2, 0. This is just 0, and this is 5 pi over 2. And 5 pi over 2, that's greater than our 2 pi, so we're going to ignore this one because I'll put it here, 5 pi over 2 is greater than 2 pi. And some of you might be saying, well, I could see this was bigger than 2 pi from the beginning, so did I even have to go here? No. If you recognize the angle that you're starting with is bigger than the limit of your largest angle, you don't even have to test it. So our one answer would be here, this pi over 2. We only have the one answer, and that is what we saw on our graph. Now this next example here involves tangent. And again, we're going to have a period change. So in this particular example, our B is 2, and the period for tan is pi over B, or pi over 2. So our period here is pi over 2. So this is a change because normally for tangent our period is in pi. So in 180 degrees we have a complete cycle. Here we're going to have a complete cycle in 90 degrees. And again, for purposes of our answers, we're going to be looking at between 0 and 2 pi, or 360 degrees. So I did graph this one also. And here is our 0. And here is our pi over 2. So you can see here, let me cover it up. Here's between 0 and pi over 2. That, let me cover this up here so we can see it better. So here's between 0 and pi over 2, 0 and 90 degrees, and you can see we have a complete cycle. Here's all our positive values, and here's our negative values. So between 0 and 2 pi on our graph, here's 0 and 2 pi. So we're looking at, our equation says, we're looking for square root of 3. Which is 1 point something. So if we look here, we can see that we have an answer over here, and then we have one over here. It's a little bit more than 1.5, and then we have one over here, and then we have one over here. So between our 0 and 2 pi, which is what we've been instructed to look at, all the answers between 0 and 2 pi, in this example, we can see we should end up with 1, 2, 3, 4 answers. Now, do you have to graph these things before you solve them algebraically? No, you don't. I'm just showing you the change in the period so you can see why when we change the period, because in this case we're going to have more cycles in our 0 to 2 pi, it's going to give us more answers. But if you want to graph these, if you have a graphing calculator, you want to do it on Desmos, so you have an idea of what you're looking at, absolutely you can, but it isn't necessary. So going back here to our equation, again, I'm going to suggest, let's say that theta is 2x. So we're just sort of simplifying what we're solving for. So we're looking at the tangent of theta is equal to the square root of, whoops, I don't know why I said square root of 2, square root of 3. And again, this is positive. So we're going to be looking for angles from our first quadrant. So we're looking in our what I think of as our normal world. Normal, right? Before everybody was stuck in their houses with coronavirus, but normal in the world of trigonometry. So our angle that has a tangent of square root of 3, this is going to be from Q1, and this is going to be pi over 3. So the tangent of pi over 3 is square root of 3. So we have our angle from our normal world. Remember, when we do tangent, we're basically looking just for one answer instead of two. So now let's undo this substitution and say 2x is equal to pi over 3. So we're setting up now with the actual information representing where we're getting our angle from. And similar to what we did for this problem, we're going to be adding that little statement that's going to allow us to find all the angles that we need. And for tangent, instead of adding 2 pi, we're going to add pi n, because remember, tangent, the period is just pi. So here is our statement where we've taken the angle that we found and we've added this pi n thing that's going to help us generate all the angles. So to solve this, what we have to do here is to solve for x, we have to divide everything by 2, or another way to say divide by 2 is multiply everything by 1/2. You can do it either way, whichever will give you the right answer. So here, 1/2 times 2x, these cancel as we wanted, and we have x equals, and now here we have pi over 3 times 2 is 6, and then here we have pi n over 2, or pi over 2 times n. Again, this gives us one angle, and we're going to, well, it's going to give us a version. We're going to start substituting in for our n's to see what we can come up with for angles that are going to be within this 0 to 2 pi, which is what our problem told us to look for. So n is 0. So when n is 0, we have pi over 6. And now here, when we put a 0 in, it's 0. So it's just, I'll put the plus 0. It's just pi over 6. So there's our first angle. Now when n is 1, we have pi over 6. When n is 1, we have plus pi over 2. And this will give us 4 pi over 6, which is, I'll put or here. When we reduce it, it's 2 pi over 3. So be careful with your addition of fractions here. You're going to need to use a denominator of 6. I'm not going to go through all that because it's going to make the video way too long. If you have questions on this, make sure that you email me or come visit me on whatever Google Chat we end up using. So when n is 2, we have pi over 6. And now for 2 up here, we have, I'm just going to write it like this so you can see it. 2 pi over 2. Obviously, that's just the same as pi, but I'm just going to keep life simple for now. And when we add these, we get 7 pi over 6. Again, you're going to be adding fractions. So I know some of you have trouble with those. Talk to me, talk to me, talk to me. And now n is 3. So far we have 1, 2, 3 answers. We know from our graph we need 4. So when n is 3, we have pi over 6. And now when n is 3, coming back up here, we're going to be adding 3 pi over 2. And this gives us 10 pi over 6, or if we reduce it, this gives us 5 pi over 3. So we have 1, 2, 3, 4 answers here. We should be done. But if we didn't graph it, we wouldn't know we were done. So we would continue on to try n is 4. So when n is 4, we have pi over 6 plus, and now when n is 4, when we put a 4 back there, we have 4 pi over, I lost track, over 2 here, which is 2 pi. So we can stop right here because 4 pi over 2, this is equal to 2 pi. So we're going to be beyond our 2 pi because we're adding this here. So we are done. If you didn't recognize that this was 2 pi, you would get an angle that obviously would be bigger 2 pi, so we wouldn't use it. It's beyond where we're looking for our answers. So here are our 4 answers that we saw on the graph.